Okay, so now you've seen a rule for how to use universal quantifiers. How about proving a universally quantified statement? So suppose you're trying to prove that everything is green for all x phi is true. How would you prove that? Well, here's the way it goes, and let me just write down the rule and then we can discuss whether it sounds reasonable. So to prove for all x phi, you should first assume or better yet, this is the language we'll use in our proofs, you should first consider an arbitrary x. Then try to prove phi for that arbitrary x. Now, what this word arbitrary means, and this will become clearer maybe when we discuss an example and hopefully more clear as you start doing proofs later on. What this word arbitrary means is that there are no external assumptions about x. So arbitrary you can think of as meaning no outside assumptions. So that means if the argument you're making here to prove this for all statement, if the argument you're making is part of a larger proof where maybe you mentioned x before and you did some things using the variable x in your larger proof, then when you start your universal generalization argument, at that point, after you consider an arbitrary x, all assumptions about x are cleared. It's now a name for an arbitrary thing, meaning something about which we have no assumptions. So here's how you might write that in an argument. So say I want to convince you, so say I'm writing the proof, I'm writing the argument, and say I want to convince you that everything is green. Then I would say consider any x, and then I would proceed to prove that x is green. So I would convince you without making any assumptions about x that x is green. So after this line in my proof, after I say consider any x, suddenly I've introduced a variable, so I've introduced this x for the purpose of a universal generalization. And this represents a bunch of arguing, blah, 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 blah. And hopefully at the end I convince you, so hopefully by the end, you are convinced that x, specifically x, that x is green. So the logical rules I'd have to use to carry out this argument would have to be whatever logical rules are associated with greenness, which we don't have any since greenness is not a mathematical property that we're introducing. But yeah, that's what you would have to do. Like somehow use the idea of greenness to prove that x is green. Then if you're done, if that succeeded, then the universal generalization is complete. And you can say, okay, since x was arbitrary, we may conclude that for all x, x is green. So we may conclude everything is green. So that's the idea of universal generalization. And unlike universal instantiation, it's not like a one-line thing that just shows up in your proof. So with universal instantiation, where you're using a universal, you like already know everything is green and you just want to apply that fact to a particular thing, you do that in just kind of a one line. It's a one-liner. You just say, okay, I know everything's green, so this particular thing here is green. But with universal generalization, it's usually a whole paragraph or a very long argument. It starts with this consider any x, and then there's a whole bunch of work you have to do to prove that that arbitrary x has whatever property is written between the bar here and the parenthesis here. So it'll usually be a much longer thing. And inside here, you might have lots of other rules going on. So the actual universal generalization is this large thing. And inside here, you could have other, you might have other rules, like proof by cases and proof by contradiction, stuff like that, all going on in here inside the larger universal generalization argument. Okay, so now we have discussed these two rules, one for proving, the one we just discussed, and one for using universally quantified propositions. And next we'll look at the existential ones.